That 60%, one of the things that have basically kept that number where it is part of firefighter physical health in general. Denise, you want to talk a little bit about how basically our physical fitness over the course of time has kind of skewed them numbers. It's kept cancer down, or some of the ill effects that we may be exposed to on the fire ground, our general well-being, how that's played a role?
I think I'll start the conversation, Tim. But it's a complex question. When we look at the rates of cancer and the rates of cardiovascular disease in the fire service, they're of concern, and we have to have more research to address them. We must have more will to implement best practices to protect our firefighters against these. But we also have to recognize that as a general workforce, firefighters are more fit than their counterparts in the general population often. And that does convey a tremendous benefit, health benefit to the firefighters when they're facing either the cancer challenge or cardiovascular. But it's just not uniform enough. We must continue to push the wellness fitness initiatives that provide protection against both of the major health challenges we're facing.
Okay, one other point before we open it up. Kenny, Gavin and I had a brief conversation, and it was described, I think it was described by one of the participants, is toxic soup. Today we witnessed the interior fire attack using our standard tactics, and for us to describe that as toxic soup, from a NIOSH perspective, you know what that toxic soup consists of. What are we talking about here when we describe it as toxic soup? We're talking about the smoke, obviously, but in a more technical approach, what do you view it as?
Well, anytime that you combust organic materials, you're going to produce hundreds, if not thousands, of different compounds. And then when you add the synthetic materials in there, you're going to get a slew of other chemicals that contain halogens, and a lot of times halogen-containing compounds tend to be, carcinogenic or have other serious health effects. So, this idea of a toxic soup is not, out of the realm of reality. There are just so many different compounds especially during the fire. The levels that we see are just pretty much off the chart. I mean, you wouldn't see that in any other industrial environment. Fortunately, firefighters, when they're inside the structure, typically are wearing the highest level of respiratory protection that's available. They're wearing turnout gear that does a pretty good job of protecting the skin. So they're doing, what they can to protect themselves. The question is, what is still getting through that turnout gear, still getting into the body? What are the exposures on the fire ground where maybe respiratory protection is not being used? What are the cross-transfer exposures that get on the skin after firefighting? These are big question marks that we need to address, and that we're hoping to address with this study to get a better handle on the pathways of exposure and the different routes of absorption that firefighters are encountering.
Gavin, let's describe the scenario. I guess we should back up a little bit. Today's scenario that we witnessed, describe that and what were the participants facing when they went in?
Well, the structure that we are continuously fighting fires in is based almost directly on the 1,200 square foot ranch structure that UL has built and has built, what, 40, 50 times up in Northbrook, somewhere around there. So it's the very similar structure. That the only difference that we've mirrored it around the center of the building, so that we can, today we burnt on the east side, and tomorrow we're going to go burn on the west side. And as soon as the firefighters get done and Denise begins torturing them in the physiology lab, Steve and his crew are out there tearing out all the drywall, finishing up everything, and turning it all around so that we can burn on the next day. But the fires themselves are ignited in chairs in 2 different rooms in the bedroom, one in a master bedroom, another one in a smaller, roughly 10-foot by 12-foot bedroom. The bedrooms are furnished with identical furnishings in each and every one of the fires. It came from a hotel surplus. I'm not exactly sure which hotel, but they had a whole lot of the exact same stuff. And we have the fires starting in the exact same place, in the exact same timing for each of these scenarios. And the 2 rooms are vented so that they have access to air from the outside. So these are not truly vent-limited fires. But we see that they will transition to flashover and they'll completely fill the structure, even with those 2 windows open, fill the structure with smoke all the way down to the knee level and below. In the scenario that we worked on today, firefighters, the attack crew went in through the front door. And again, taking a step back, we have all 12 of our firefighters involved in a coordinated attack type scenario. So we're looking at exposures in 3 different levels. Interior, so those are firefighters that are attacking the fire with a hose line and also doing a search and rescue. Looking at exterior operations, so firefighters who are working in an engineer role, in an incident commander role, and an outside ventilation role, so not actually inside the structure during the fire event. And then the last 4 firefighters are largely exposed during an overhaul type of a scenario, where after the fire has been struck and the victims have been rescued, they will go in and do an overhaul and basically tear out the 2 rooms that have been set to fire. So each of the scenarios are very similar except for the type of the attack, whether we're doing the interior attack, which we went today, and tomorrow the same firefighters are going to go through and we're going to do a transitional type of attack where we put water in from the exterior and then transition around and take the hose line in the front. And while they're doing something different, their actions are going to change the fire ground for everyone else that's going to be working after that. So they will be doing the slightly different tactic. All the other 10 firefighters will be doing the same thing, but what they will be exposed to, what they will experience, will differ based on what the attack team does.
My question is directed mainly to the UL guys. You talk about how we've done this same style ranch so many times before. I think a lot of people would be interested to know what specific you guys were looking for, maybe data-wise, with this setup, and especially how it ties into all the other data that we're collecting.
So the beauty of using a layout that we have used in the past is we're able to build on all the data that's been taken in the past. So we now have 20+ horizontal ventilation scenarios where certain doors and certain windows get opened. We have a dozen vertical ventilation scenarios. We also are getting ready to do some more fire attack scenarios. So when you use where the ranch house came from was essentially we were trying to look at the housing stock in the United States and kind of bound our problem. So we would take a smaller ranch house that's fairly compartmented. It's got walls and doorways separating all the rooms, and we typically counter that to a 2-story, 3,200 square foot colonial house that has an open floor plan, 2-story great room, 2-story foyer, kind of a modern home layout. So when we do all of our scenarios, that's kind of how we bounded the problem. When we talked about getting into this is our first attempt at essentially human subject testing in an actual fire environment. So we wanted to start with more of a known fire behavior. We wanted to make these fires, while real, as predictable as possible. So we wanted fire behavior that we knew pretty much what was going to happen. Being that we had burned in this layout 30+ times, we were pretty confident we were going to get. And we also did a pilot burn early on, so we looked at a worst case scenario to be really comfortable with what we were going to get. So we know when you all go to interact with this fire, we know exactly what measurements to look at to make sure that you're having the progress that we want you to have early on, and then as soon as that positive progress tends to happen, it tends to go right throughout. So that's really the background as to why this structure and why this particular layout. One thing that we did do different here is that there is 2 rooms of fire to give that extra component. But the big component here, as Gavin talked about, was starting with those 2 windows open gives us a very predictable fire behavior. So as you open that front door to introduce another flow path, we know exactly where we need to pay attention to, which is pretty much between the bedrooms, the hallway, going through the living room and out the front door. So as you attack that fire and you control that flow path, you've got vents opposite you, and it kind of controls where that fire is going to go.
The other thing excuse me, that I like to see measuring here, being at a lot of the test burns at UL, is that we're actually measuring what's going on with the victim and what the victim is experiencing here. And we can actually start to see the choices and tactics that we have and how it translates to the victim's experience. So we can start to put that in some numbers.
Sean, I think that's an important point that I don't want to miss here. Gavin, can we talk about that a little bit? During our initial discussion, we talked about the mannequins are being monitored, and we're talking about a victim who is known to be in a safe place behind a door, which has been proven by UL to be a safe place for a period of time. Now our tactics, our traditional tactics to no one's fault, has been get that victim, drag them out into a toxic environment. Talk about that a little bit, and maybe what we end up learning by, I won't say the end of the day, but when the course of this research concludes.
Yeah, by instrumenting the victims the way that UL has done, we can track what we are exposing our victims to, whether they are in a safe environment before the firefighter interaction with them, or whether they're not in a safe environment, depending on where we're at. The ability to have portable data acquisition systems and to tie that in with the built environment, as well as the portable data acquisition systems the firefighters have on them. We can see, what are we doing? What are we possibly introducing our victims to? And again, this goes back to the tactics. What is the tactics that we choose to do? The common search tactics. How does that potentially expose the victims to either increases in temperature or some of the gases that we know are in that environment itself? So another one of those tactics, again, not just the interior versus the transitional attack, but how do we truly interact with the environment as well as the victims that are in there right now? And we saw a little bit in the pilot data when we ran that pilot test it was about a month and a half ago now. We saw some very interesting things. I don't want to give it away too much since our audience still has to go through a couple more scenarios. But we saw some very interesting things that showed up. And one of the things I think will be a very interesting and new outcome from this is we're starting to understand more about that victim themselves. And so keep your eyes out for that data as it comes out.
And that came about. That wasn't initially planned. It was just how this research has kind of evolved to the circumstances.
Exactly. That's the great thing about working with some of the experts that we have here. We designed this study over conversations for years and then put a proposal in about 2 years ago. And then we're constantly changing and adding things. Adding the sensors on the victims, that was not one of the initial outcomes, but we said, hey, this looks interesting. Steve went out and bought, a couple $1,000s worth of cool toys, and we got them taped to the head of the victims now. So we get the first view of that.
I just want to build on that a little bit, just real quick. In the past, what we've done is we would measure the entire environment. So we're looking at every foot in every room for temperature. We're looking at gas concentrations in several rooms, heat flux. All of the things could potentially adversely affect the survivability of occupants. And our thought process was, we're essentially placing victims everywhere in the house. That we're looking at conditions everywhere, and that didn't get seen that way. So we physically have rescue Randys that are being rescued during these operations, and they have a GoPro camera right where their eyes would be. So we've seen some interesting footage as the rescuers come upon all of a sudden you see two heads looking over top. Yep, it's a victim, and then they grab them and they move them out, as well as a temperature sensor at the mouth and a 6-gas meter right on the cheek. So we're looking at oxygen, carbon monoxide, carbon dioxide, hydrogen cyanide, and a couple others that are we feel would go into the calculation to determine tenability.